Greetings, I'm Gigi Barnhill, and I'm president of the board of directors of the Historical Society, and welcome to you all. We have some new faces, so I think that's great. And I would encourage you afterwards to sign the visitors register out on the table against the far wall. But today we have George Greenstein, who's speaking on Martians and a Hole in the Sky. Amherst astronomer David Todd. I suspect you all know our speaker better than I, but in case you don't know, George taught at Amherst College from 1971 to 2012, where his research focused primarily on neutron stars and pulsars. He was active in designing new seminar-style methods of instruction in the sciences and has written numerous popular books on physics and astronomy. By remarkable coincidence, his first home in Amherst was Todd's final home. And I just think it's a delight that we're hearing this today. There's been so much in the news lately about travel to Mars, and of course the Eclipse. Total Eclipse brought a great deal of popular interest in astronomy, so I'm glad we're part of this great movement. So please welcome George.
Yeah, so there's my home. Terry lived there. Anybody else live there? It's a small community. Little town.
Just like my office.
I couldn't believe it when I arrived at Amherst College. You know, I'd been a student living in student homes, and postdoctoral fellow, and Amherst College said, "Would you like to live there?" And I simply couldn't believe it. And nice house, it's on Smell Street. You have the next. And even as I was unpacking the boxes, I took a little walk into the backyard, just in the midst, you know, U-Haul trailer unpacking, and I took a walk in the backyard. And I saw this is the backyard, and little woods back here, but it looked like just a very shallow, you know, there seems to be something behind those woods. I got the sense that it was a very narrow, just little stretch of trees, and so I pushed my way through those trees, and that's what I saw.
Oh, nice.
In my backyard. So I thought that's nice. And next. And it's been around a long time. On the cornerstone, it says, I think it's 1905. Notice there are two domes. There were two domes back, and now there's only one. A terrible fire in that room, and it burned up the telescope above it. And so that's what happened. Okay, can we go forward now? There's a picture of the telescope. It is an extraordinary sight. It would just barely fit in this room diagonally. It's huge. And there are public showings in that telescope. In the summertime, you can go look at the telescope and look through the telescope. If you're interested, the name of the group is very easy to remember. It's called the 5 A's. Yes. Amherst Area Amateur Astronomy Association. And they hold public showings there. Next picture. That's the person who built that telescope, who arranged for it to be built, David Todd. 1855, 1939. And most people in Amherst know of him as the poor, long-suffering husband of David Todd. But let me tell you, I want to say two things about him. First, he gave as much as he got. Secondly, he was quite an interesting scientist, and I want to talk about him. So let's go on. There were two main areas of research of David Todd that I want to talk about, and the first is eclipses. Now, we all had an eclipse right here recently. Did anyone see the total eclipse? Total. I mean, did you travel? Where did you go to?
Idaho.
Idaho.
Nebraska.
Nebraska. Anybody else? Okay. Did you get a clear view?
Yes.
Oh, good.
You're lucky. Okay. Next slide. There are two kinds of eclipses. Eclipses of the moon and of the sun. And what causes them? An eclipse of the moon happens when the Earth's shadow falls on the moon. And you might be sort of thinking, what? We're all familiar with shadows. You walk down the street and you cast a shadow on the sidewalk, but the point is, but the point is that maybe we're not familiar with the thought that everything is casting a shadow. The whole world is casting a shadow. So I brought along a world.
Beautiful.
And it's the right color, blue and white. The Earth is blue and white. So let's imagine there is the sun. So right there, you see right over there, this brilliant light bulb right there. And here is the world, and it's illuminated by the light bulb, and it casts a shadow that's running this way. If the light bulb is right over there, then the shadow that the whole world casts is running off into space. You and I, we never see that shadow, ever. But we experience it every 12 hours, because that's what night is. Night is when we move from here to here. The rotation of the Earth carries us from the illuminated part of the Earth to the nighttime part of the Earth. So the sun's over there. This part is in the night. Here's another little ball in space, the moon. And the moon is smaller than the Earth, so yes, the moon is smaller there. The sun is illuminating the moon also. And if this is the configuration, the sun's over there, then we on the Earth can see the moon. But if the moon's over here, we can't. Next. And if you're anywhere around the world, the Earth, and the moon happens to be over here, you'll not see the moon anymore. Or rather, what you will see is extremely dim, just barely visible. Quite a sight. There was an eclipse of the moon, 2 or 3 years ago. Did anyone see it? The moon was just blood red, just barely visible. Okay, next slide. An eclipse of the sun happens just the inverse, not when the Earth's shadow falls on the moon, but when the moon's shadow falls on the Earth. In this case, the configuration is like so. Here's the moon. There's the bright light bulb of the sun. The moon has a shadow which goes over here and falls on the Earth. Now just notice, the moon is smaller than the Earth, so the shadow is going to be kind of small. That shadow, if you were standing right in the middle of that shadow, the moon is perfectly blocking our view of the sun, and next, can only be seen from a few places. You got to go to where it's happening, because the shadow is kind of small. It lands on the Earth. We in Amherst were up here. We only got a partial blockage. You two guys had the experience of going there. Now let me tell you, it is an extraordinary experience. I've only seen 2 eclipses, and to me they were electrifying events. I had this vivid sense that I was seeing a hole in the sky. But I was seeing a hole in the sky, and just this blackness in the midst of the sky. You've got to be in just the right place to see. This is the path
We're getting ready.
of the shadow in 2017, just in August. It started out, this is the shadow of the moon. It started here and was moving along here. It goes almost 2,000 miles an hour. And that shadow is maybe 20 miles across. And the last time I saw it, I saw the shadow coming. Quite a sight. And let me tell you, you want to see a total eclipse. There is no comparison between a partial eclipse that we saw in Amherst and a total. You have a chance. Just make sure you live long enough in 2024. It's going to pass right through here. Here's Amherst. Path of totality is going to be up there.
Go up 91.
91 is it. Why was David Todd interested in these things? I mean, we're all interested in them because they're thrilling. He was interested because it was a chance to see the atmosphere of the sun. Now, I know what you're thinking. You're thinking, I didn't know the sun had an atmosphere, and that's right. You've never seen the atmosphere of the sun. You can't see the atmosphere of the sun because the sun's too bright to look at. There's only one chance to see it, the atmosphere of the sun, and that's when the big thumb blocks out the sun, namely an eclipse. Now, I called it an atmosphere, but that's not the right term. It is utterly unlike anything the Earth's atmosphere has. It is a new thing. And in David Todd's time, people knew very little about it. They knew it was radically different than the Earth's atmosphere, but they didn't know much about it at all, and he wanted to find out. So he went to where it's going to be. and he went to Japan in 1896. Now, nowadays, if you want to go to Japan, you'll maybe drive to Boston, and you'll get in a plane, and one uncomfortable night later, you'll be in Boston. David and Mabel went to Boston, and they didn't come back until October. They left in June, and it took them from June to October to go to Japan and then come back. An eclipse lasts around 2 minutes. And in that 2 minutes, they were going to jam every possible study they could. The first step was to go to Boston. The next step was to get to the West Coast. And they took the Transcontinental Railroad, and the Transcontinental Railroad was new in those days. It was a new thing. It had been built around 30 years prior to this point. So simply getting to the West Coast was a big deal. And then that's how they got to Japan, sailing. Okay, next slide. When they got there, they set up a big, complicated set of equipment. This is the main building. All sorts of things inside. These are flaps that come down to keep it from the rain. There's equipment here, equipment here. They were going to pack an enormous number of observations into 2 minutes. And this is a gadget that David Todd built. David Todd was an extraordinary gadgeteer. He was a master inventor. And electricity was a kind of a new thing in those days, okay? All of these various telescopes that were many different instruments that were going to observe the sun. And they were doing it in a highly choreographed dance. Just as choreographed as an exceedingly complicated dance with a large number of people that's got to be jammed into 2 minutes. There are about 400 exposures with all the instruments in 2.5 minutes. David Todd was really a remarkable builder of instruments. And when he was younger, before he came here to teach, he was asked by a friend and colleague of his to join forces with that friend to invent gadgets. And David Todd took it very seriously and thought about it, and decided no, he was more interested in astronomy. That other person was Thomas Edison. Next picture. On the day of the eclipse, it was cloudy and it was a total failure. This is a drawing. Nobody could do the photographs in those days of the atmosphere of the sun in a Japanese publication. Elsewhere in Japan, it was clear. Next picture. He didn't give up. This was not the only trip he took. My understanding is Mabel wrote a whole book about the Japan expedition, but this was not the only. He went all over the world studying eclipses, and in particular this thing. Next picture. Okay. We don't need eclipses anymore. Nowadays, we have instruments in space that produce artificial eclipses constantly. And this is a modern photograph taken by a spacecraft of what I call the atmosphere of the sun. It's the corona of the sun. It's not even air, it's a plasma. And the plasma is influenced by a magnetic field. And the sun has an exceedingly strong magnetic field. It's a violent, chaotic magnetic field. And the patterns in the plasma is mapping out the sun's magnetic field. Next picture. This is an actual photograph of the surface of the sun, taken from a spacecraft. This is the sun. There is a way not to black out the sun, but to reduce its intensity. So you can see this is the plasma, the corona, surrounding the sun. You can see there's these superheated regions here, and these arcs. These arcs are magnetic field lines, and these are sunspots. A sunspot in visible light is darker than the rest of the sun, but in other forms of radiation, it's brighter than the rest of the sun. And these sunspots are the regions where the magnetic field of the sun pokes up out of the surface of the sun. The magnetic field of the sun is violently churning, and there are explosions on the surface of the sun which send huge bursts of particles out towards the Earth. These particles, plasma, are affected by the magnetic field, and they're affected by the magnetic field of the Earth, and they're guided to the North Pole and the South Pole, and we got auroras. On one occasion, there was an explosion on the surface of the sun that was so great that it knocked out the power grid for most of Canada. So that's the atmosphere of the sun. In David Todd's time, people were only just beginning to get an understanding of what's going on. Okay, so that was one of the things David Todd worked on. Next picture. He was interested in Mars. Mars is one of the closest planets to us. Close, it's 46 million miles away when it's closest, and other times it's much, much farther away than that. As here's the sun, as we orbit the sun, and as Mars orbits the sun, sometimes we're close to each other, sometimes we're not. Right behind you. That's a pretty good picture of Mars taken from the surface of the Earth. This is kind of the view that maybe David Todd would have had looking through the eyepiece of that big, gigantic telescope on Snell Street. It's red. Mars is the red planet. You can see that with your naked eye.
Yeah.
Alan, when is Mars up nowadays?
Sorry?
When is Mars visible?
No, early morning right now.
Early morning, you can get up and you'll see Mars, and it's red. It's clearly red. Mars, the god of war, blood red. It's also got sort of these dark splotches down here. And the interesting thing about those splotches is they change as the seasons progress, the Martian seasons progress. They're sort of greenish, darkish, and they get bigger or littler depending on whether it's summer or winter on Mars. And then, see this thing, they're polar caps on Mars. Now, in those days, this is about the best you could do. And astronomers looked very hard at Mars when it was closest, and this is when it's closest. And it's extremely hard to figure out what's going on. But next picture. Giovanni Schiaparelli thought he saw things he called channels on Mars. He's Italian. The Italian word for channels is canali. It got translated as canals. It was one of the big scientific mysteries of those days, and that mystery lasted for something like a century. Were there canals on Mars or not? Some people looked through the telescope and they thought they saw these little straight lines, and other people looked through the telescope and really could not see straight lines. When I was a kid, it was not known whether there are canals on Mars. When I was in college, it was not known whether there are canals on Mars. One of the people who was very interested in this was Percival Lowell. Lowell had a lot of money. They named a city after him. David Todd had a telescope. Lowell was interested in Todd, and Todd was interested in Lowell. And at one point, I find it's hard to believe, but they took that huge telescope down to Chile to observe Mars. A story got told that, let me just mention, the Suez Canal was built around 20 years before the period of time I'm talking about. So that enormous engineering feat was sort of in the air. The story became that there were intelligent life on Mars, a civilization, and Mars was drying up. That red thing was a desert. Can we back up to the picture of Mars? You don't see any oceans, you don't see any lakes. It's just a desert. So now forward again. And these canals were built to go up to the polar cap and take water down to the equatorial regions.
There we go.
Ballooning was kind of new in those days. Radio was new in those days. David Todd was a pioneer. This was a new thing. He wasn't, that's not quite right, he wasn't going to signal Mars. He was going to listen to see if there were any transmissions from Mars. Well, there was no follow-up to this thing that I've been able to find, but let me tell you, he did not find any signals from Mars. Next slide. It was not until I was in my mid-20s in graduate school that the first spacecraft flew by Mars, and it did not show canals, it showed craters. I'll never remember the shock of that, seeing it in the newspaper that day. This is a view of a spacecraft, this is a view of Mars, of a spacecraft on the way to Mars. And I want to tell you about that spacecraft. It's called Curiosity. It's on Mars right now, and it's driving around. Sending a spacecraft to Mars is an absolutely amazing technological feat, and I want to describe it a bit. If I wanted to drive to California, I would get in a car and I would drive. But suppose I wanted to take a stone and throw it to California. For just, maybe 1 second, I'm pushing with my hand and then I let go. And it flies in this huge arcing path until it gets there. That's what a spacecraft to Mars is like. There's a period in which the rocket is firing. I don't know, 5 minutes, 10 minutes, is exerting this monstrous force on the spacecraft. And it's throwing it towards Mars, and then it's over. Within 2 minutes, 3 minutes, 4 minutes, that spacecraft is defunct. It sort of falls away, and the spacecraft floats off, and that spacecraft is a stone that takes 9 months to get to Mars. And nobody's controlling it. It's helpless. It's simply flying freely through space. And the aim is so good that, in terms of my analogy, if I were to throw this thing, it's as if the mayor of Los Angeles were to take and put his hand like that and hold it up, and my stone landed right in it. The accuracy of that Curiosity rover was equivalent to landing something within 1 inch of the trip to Mars. The landing sequence was, to me, the electrifying part of the whole story. It has been known among engineers as 7 minutes of terror, because the landing sequence took 7 minutes. And these engineers were helpless. They were not in control. This thing was a robot, and it landed itself. It hit the top of the atmosphere of Mars at 13,000 miles an hour. What it was at that point was something like a flying saucer. It was the actual Curiosity itself was encased in this flying saucer, which would have fitted very easily inside this room. It maybe would have gone from that wall to the size of that flying saucer. 13,000 miles an hour. So it's down to 1,000 miles an hour when a parachute deploys. With a violent bang, now this thing is violently swinging back and forth under a parachute. The bottom of the parachute drops out. This amazing picture was taken by another spacecraft that was passing overhead when that was happening. And let me tell you, that was not an accident. There are various spacecraft orbiting Mars, and they timed the takeoff of Curiosity so that 9 months later, this spacecraft would be passing overhead. There you see the parachute with... This is now taken from the Curiosity rover when the bottom of that flying saucer has dropped out. It's now being lowered by a parachute, going just a little bit less than 1,000 miles an hour, and there's Mars. There's some of those dark splotches. This thing is the bottom that's falling freely away. Rockets turn on when it's got radar looking down to the ground. 65 feet above the surface of Mars, it comes to a halt. And now a crane pays out, lowering the Curiosity rover till it touches the ground. Cables are cut, boom, this thing flies away. And there's Curiosity on Mars. An incredible technical achievement. Now, what is this thing doing? Mostly what it's doing is looking for signs of water. And now we're coming back to Schiaparelli and this ancient story. Water is the key to life. Our bodies are mostly water. We drink and just try going without water for a few days. Most living things are made out of water. Tarantulas are mostly water. Every living creature on Earth is mostly water. And there is abundant evidence that there used to be water on Mars. And this is one of the primary tasks of this thing. This is, more than anything else, a geological laboratory. It's driving around studying the mineralogy of Mars. It has identified rocks, minerals that can only have been formed in water. The orbiting spacecraft that are orbiting Mars have mapped the surface very carefully, and they have found what seems to be an ancient lake beach. So it's quite a fascinating situation because there cannot be any water on Mars now. It's too cold. And not only that, a more subtle and complex problem is there is air on Mars, but very little. And in the very low pressure of the Martian atmosphere, water can be a solid and it can be a gas, but it cannot be a liquid. Have you ever seen a cake of dry ice? Take it out of the freezer and put it on the ground, it does not melt. It becomes a gas. Same thing with H2O on Mars. So if there used to be water on Mars, that means Mars used to be warmer and it used to have more air. And that's interesting. Well, David Todd was an early pioneer of Martian studies. That's what Mars looks like nowadays. Looks like the American desert, really. I would love to go there. To me, the most amazing thing was that I would weigh around 50 pounds on Mars. This is the person who named the Curiosity rover. Clara Ma. She was 12 years old. NASA, before the thing took off, put out a call to schools saying, we're looking for someone to name this instrument. Clara Ma wrote the winning essay. It was a beautiful essay about how curiosity is what drives us all. She is now applying to college. She's 17 right now. So back to the beginning, our beautiful home, my beautiful home. Notice this very characteristic, very unusual thing here. It's a curved stairway, okay? It's curved. There it is again. David and Mabel's home had been my home. And so the whole time I was living in that house, and ever since then, I felt a kinship with David and Mabel. With David. I felt a really strong kinship, and I want to illustrate that kinship very vividly. So thank you very much. Pauline, will you turn on the lights? Estella, take a bow, will you? Mabel herself.
Would you take a few questions?
Millions of questions.
So, are there any questions?
There was a picture with the big hoop of plasma on
Yeah.
the sun. Was that hoop 1,000 miles high or 1 mile high?
Much bigger than the Earth.
Oh.
The sun is gigantic. The sun is, I don't remember how many miles across it is, but it's very much bigger than the whole Earth. That arc is magnetic lines of force coming out of one spot and terminating in another. So it's not a thing. It's a region of intense magnetism that is trapping the plasma, the atmosphere of the sun. There are much tighter loops. Furthermore, they're constantly changing because the sun's magnetic field is violent churning.
Does that affect our global temperature? Is that why we have global warming?
You know, there's a fascinating, possibly, not global warming, no. There was something called the Little Ice Age in Europe in 1815. That was a time when there were no sunspots.
Really?
There was this very,
Someone without.
no, actually, no, I'm thinking of something else. There's a painting by, not Bruegel, but some other painter of people ice skating. And that was at a time, this is what I'm thinking of. It was a time when summer never came.
Yeah.
And it was at a time when for many, many years there were no sunspots. It's called the Maunder minimum. Maunder was an astronomer who was tracking sunspots. I think that Bruegel painting was several centuries before this 18 something.
Right, yeah.
That was 16 something.
How did they track the sunspots without these powerful telescopes?
Galileo saw sunspots through a really mangy little telescope. Some of them are quite large. The hard part is if you can not look at the sun through your naked eye, you can definitely not look at the sun through a telescope. You need something in front of the telescope to block 99.999% of the sun's light. Galileo had that. Anybody could do it. You could do it. Take a pair of binoculars, and if you got one of those sunglasses that is good enough to look at the eclipse, you can, with your naked eye, see sunspots. Or take that in front of a really small pair of binoculars and you'll see sunspots just fine.
What did they use in Galileo's time?
What?
What did they use to block those?
I don't know what he
Galileo's?
used.
Smoked glass.
Maybe smoked, smoking glass,
Smoked glass.
smoking glass or something like that. Don't know.
A local question. Did Tinker Thompson accompany the Todds on their Japanese trip?
Who's that?
or-
I don't know who that is.
Who's a local mechanic, mechanical genius, who
Okay.
apparently worked with
I see.
David Todd on
Okay.
a number of his expeditions.
I've never heard of him and I didn't know this and I don't know. Thank you for mentioning that. Yeah.
A couple further thoughts I picked up somewhere about David Todd. One, his colleagues referred to him all of his life as Cloudy Todd.
Cloudy.
Second, you had a newspaper clipping of going to Russia. That was timed just before the revolution and he had to come home. Never happened.
Yes.
Further, the Coronet, the yacht that you showed, I believe there's a restoration of that vessel, or one like it, going on at the Tennis Club in Newport, Rhode Island.
Yes, that is correct.
How cool.
And the coronet.
Yeah.
All right.
Field
the-
trip.
For the field trip.
The yacht was loaned to him by some affluent classmate or
Right.
friend.
All right. I see.
There are pictures here in the building of some of the equipment that went along. Immense things.
Can you show us?
I'm no longer president. They have pictures around.
Yeah, you'd have to come in another time.
Oh, you mean they're not out?
They're up somewhere in
Yeah,
a box.
somewhere.
Okay.
Yeah, that's,
All right.
who knows?
It's sad, of course. David Todd had some terrible mental illness, and the last decades of his life were destroyed by that illness. It's a sad story. Other?
Well, thank you so much.